So Alex Kingsbury is here to talk about additive manufacturing, which in plain English is about 3D printing titanium.
Hello, I'm here to talk to you about, this is on, yeah? Thank you. It's a very cool topic of 3D printing. Anyone know about 3D printing, heard about it, knows what it is? Yeah, it's fairly well known. So specifically we do 3D printing with metals. There's a lot of application in metals, but it's in need of research. There's some pretty cool parts. I think I'm actually picking this back, sorry. So yeah, we've got the highest titanium reserves in the world, yet we don't have a titanium industry. And when our manufacturing industry is in decline, that's a bit of a concern for us, I think. So CSIRO will solve the problem, right? Additive manufacturing is by definition a kind of layer by layer process. You add layers and you build your part up as it should be, as opposed to its corollary, which is subtractive manufacturing, where you subtract material away to create a part. It's reliant on a CAD file and that's sliced into pieces and it gets fed to the machine. It's got huge advantages in complex parts, as you can see up here. That's a cutaway that we've actually printed because it's much too hard to machine it. And the other one was a chess rook, which is pretty cool. One thing that additive manufacturing has a huge advantage on is supply chain issues. So if you've got various different parts that you're sourcing from all over the world, you can print a whole part in one piece in one go. You don't need to rely on a number of different people for your parts. There's no welding involved, so you're reducing your weld time. This here is a series of fish tags that we did for our colleagues in Hobart. This is a really good example of rapid prototyping. 3D printing is also known as rapid prototyping for this very reason. And the thing about additive manufacturing is you don't design it for your traditional type part, you design it for additive manufacturing. So when you design it for additive manufacturing, you make it better. And generally, you end up with a much superior product. We also do fun and frivolous things, such as these cool little things. This is a part nested within a part. You can actually do that in a 3D printer. And we do jewellery as well. That's a local designer that's made some jewellery and is selling it today. So it's a really good example of something that's actually in business now. This is also another good example of a business. We 3D printed some bike lugs and they join them together with just off-the-shelf tubing and they custom make a bike for you. 3D printing is great for customisation. I want one for Christmas. They're very expensive. 3D printing is great for biomed applications. So particularly titanium, it's very biocompatible, it's corrosion resistant, and if we're 3D printing it, we can custom make it to someone's body shape and anatomy, and that means, generally speaking, it's a very high success rate, very low infection rate, and so on, all those things that are important to orthopaedic surgeons. This is my picture of a cute kid that asked us for a dragon. We had to comply. We printed her one. We anodised it blue, and that got a huge amount of publicity. And so that's one thing I wanted to tell you all is that CSIRO actually has a great comms department. We do great publicity and we get heaps of press. This is my last slide. This is Chad. He's our lab manager. He's very friendly and he's very nice. And if you go to our website and you go to additive manufacturing, then you're going to get hold of him first. So it's good to have a face to a name. And he's the one that can 3D print you up whatever you want. Thank you.
So in terms of like areas in which like 3D printing, I guess we'll talk about titanium, is like really going nuts. Is there one sort of industry vertical or consumer vertical or some space where it's like everyone's kind of piling on board, or is it a bit early for that?
Yeah, so you can buy a 3D printer from Officeworks. I think they're a couple of $100 or something. They print in plastic. And the plastics basically are about 5 to 10 years ahead of metals. Metals have a little bit way of a longer bit to go, and they're much more complicated by nature anyway, particularly when you're making like structural parts for aerospace. Aerospace is a big consumer of 3D printing. And at this point we're really got areas where you want something custom, where you want something complex, and it's got to be metal. That's where it's really taking off.
Yeah.
But those applications are pretty much, aerospace, automotive, biomed.
Yeah.
And at this point, we'd like to see it become a much more mainstream thing, and ideally see industries coming up within Australia.
I thought the point that you made about parts was really interesting, and the kind of reconfiguring of global supply chains. I mean, if I've got a gizmo that has got a part from Taiwan and a part from South Korea and a part from the US and a part from Europe, and one of those parts goes bung.
Yeah.
My choices are I have a whole bunch of stock, which costs me money, or if I could 3D printing, then I can get it back online straight away. So that's a great vision.
Absolutely.
Is that how far away is that vision from? Is that this year, next year, 10 years?
Yeah, 10 years is a typical horizon that we talk about in metallic additive manufacturing. I think that's a great point that you make, because I think that 3D printing has the potential to completely reinvigorate supply chains and turn them on their heads. We have a world where we have standardised parts from a very long way away. We can, with 3D printing, go to a world of customised parts from, just next door or down the road.
So do you think that might, Australia is at the end of a whole bunch of, it's a long way to Australia anyway you slice it. So is 3D printing potentially going to make any difference in terms of Australia as a place to do advanced manufacturing?
Yeah, that's a really good question. So additive manufacturing has a fairly low labour requirement. One of the biggest barriers that we have to manufacturing is our labour costs. They're very high in Australia. So by being able to reduce the labour required per unit, that's where we see this being a real advantage to Australia in particular.
I guess my last question is, so just follow on, so you kind of said that if you're doing a subtractive manufacturing piece in additive manufacturing, that often there's a redesign. Who is that person that does the redesign? Are they presumably, they've got designer in their job title, but what kind of a designer are they? And do they come out of industrial design or graphic design or fashion design or what?
Yeah, and I guess it depends on the end product in mind. A lot of aerospace companies are doing a lot in additive manufacturing, and they're the ones pushing that design, and that's very much an application.
So it tends to be the same
design.
people who are designing the subtractive manufacturing thing that then go on to design the additive manufacturing thing?
Yeah, but I mean, there's a real argument though for additive manufacturing is a completely different manufacturing paradigm. So, having something with a subtractive manufacturing mentality in mind actually is not particularly productive for additive manufacturing. A lot of our products are designed around subtractive manufacturing design, so you have to machine them less and so on. So
I feel like there's some kind of divide there, which probably
it's
don't.
not actually. So one thing that's really good is rapid prototyping. So we can do rapid prototyping, but then what we do is we'll do a business case. It might make more sense to 3D print it, but it actually might make more sense to 3D print the mould that then you then go and do your casting.
Gotcha.
So yeah, it definitely works hand in hand.
Great. Question?
Oh yes, people like Remco, etc. would be far cheaper than to manufacture parts, and they wouldn't need the mould, as they were, to make each, say, screw or whatever they need for their particular car. Would that be true?
Yes and no. At the moment, our feedstocks are quite expensive. So that's something that we're working on, is reducing the feedstock cost. There's some things, and you wouldn't particularly know it intuitively, where the business case for additive manufacturing is there, and there are some things where the business case is not there. So it's really a case-by-case basis type thing. We ran a workshop a couple of years ago on ultra cheap feedstock material, and basically what we came back to was we just need something made of steel because steel is really cheap. We couldn't get much more inventive than that.
Question here.
With 3D printing, say, plastics, smooth and dip in acetone or use fine grain with plastic, those examples that you had look quite coarse.
Yes, that's a very good point. So,
Can you repeat the question?
yeah, sorry. Gentleman asked, the parts that I showed up look fairly coarse. And actually I was thinking, gosh, I should have bought some of my pieces, that we can all touch them and play with them. And yeah, that's true. They've got a fairly rough surface finish. That in particular is because of our RCAM machine. So RCAM is an electron beam 3D printer. It uses a 50 micron powder, like a larger size powder. And basically the smaller the size of powder you use, the better your surface finish is going to be. So I currently have on order another type of printer, and it's arriving next year, and that's a laser-based system, and laser uses fine powder, and it's going to give a much smoother surface finish. Having said that though, there's still generally some sort of machining if surface finish is really important for the application.
Next question.
Yeah, just be interested in the comparative strengths between additive manufacturing and subtractive manufacturing. Is there a big difference in the strength of the final product, or any difference?
Oh, like properties wise? Yeah, that's often a question that gets asked. It's a bit of a yes and no answer. We can basically design or maintain operating conditions to optimise a part for certain qualities and properties. As far as comparison to wrought, we get basically a static dynamic type property, roughly the same with wrought. It's probably a few % off though, and yeah, so it's probably a better in application when you've got a specific property in mind. You can design it for that property. And the other thing as well is that when compared to wrought has, and welds, if you've got a welded part, has a lot of variation across the part in its properties, whereas 3D printed is very uniform.
If you know what you want, you can get it. Yeah.
Is there a scientific reason
Yeah, we're doing like commercial purity titanium. We're doing titanium alloys. We're also doing cobalt chrome. And our new laser printer will be able to handle a whole lot of extra materials as well. Like I said earlier, we focus specifically on titanium just because titanium in particular is hard to machine. It eats through tooling. So it's not actually a great type of material for subtractive manufacturing anyway, but it performs beautifully in an additive system. And also, added to that, we've got like I said, the highest reserves in the world of titanium, but yet no titanium industry. So it's a real perfect opportunity to start to...
So are we the world leaders in 3D printing titanium?
Yes.
It's good to know, right? It's good to know.
Yeah.
It's good to know.
Sure, we're definitely up there. We've got the only RCAM machine in the Southern Hemisphere.
Spoken in the true style of an overstatement.
But it's very much a collaborative thing. We're not in competition with other research organisations.
But we got the most titanium, right?
We've definitely got the most in the ground.
One more question.
Yes.
Is the additive manufacturing process producing a porous product?
It can do, so it's 100% dense. That's our ideal state, and that's what we achieve with an RCAM machine. Having said that, there is a lot of demand for porous product as well, and we have another technology that is an additive manufacturing type of technology. I didn't actually talk about it tonight, but it's called cold spray. Cold spray is where you blast metal particles at a substrate and you start to build up a part that way, and it's got kind of pros and cons very different to like an Arcam 3D printer. Cold spray is not a 3D printer, but using cold spray you can definitely adjust porosity according to what you need, and they've done quite a lot of work in that type of area before. Yeah.
Alex Kingsbury, Additive Manufacturing.